Section 3.2. Here are our half-angle identities. So given an angle theta, find the trigonometric ratio of an angle half the measurement of theta. Use the correct quadrant for the angle to determine if the ratio is positive or negative. So you'll notice on each of these identities they have a plus or minus. That doesn't mean there's two answers, a positive answer and a negative answer. That means we have to figure out what the quadrant is to figure out whether it is positive or negative. Okay, so we're going to start by finding the cosine of 15 degrees. We did this in section 3.1 using a difference identity. So this time we're going to use a different method to find the cosine of 15 degrees, and our answer is going to look different, but I'm going to show you that it's actually the same value. Okay, so cosine of 15 degrees. 15 degrees is obviously a quadrant 1 angle, so it's going to be a positive ratio. So we don't need our plus or minus, we just need the positive answer. We take our cosine formula, which I just realized I wrote wrong when I started this problem in class. So I was using the half-angle formula for sine. This is the half-angle formula for cosine, and the only difference between the two of them is that one is a plus and one is a minus. So this one, the cosine one, is a plus, and the sine one is a minus. I have never learned a creative way of remembering this one. So if anyone has something you use to help you remember, that would be amazing to know. Okay, so then we're going to plug in. I'm going to rewrite this so it's going to be a little easier to simplify. So we have the square root of 1 plus the cosine of 30. And the cosine of 30 is square root of 3 over 2. And then that whole thing is divided by 2, and all of that is inside of this radical. So let's see how much we can simplify this. I'm going to zoom in a little bit so it's easier to have space to write. And I'm also going to clear out this little explanation. Alright, here we go. So view, zoom to 300. Okay, good. So let's go ahead and get our common denominator on that 1. So we'll have 2 over 2 plus square root of 3 over 2 all over 2. Which gives us square root of 2 plus square root of 3 over 2. Just combine those fractions together. I just got a common denominator on my 1 so I could add it to the other one. And that whole thing is divided by 2. Okay, so we have a fraction over a fraction, well, over a number, inside a square root. It's a little bit crazy. So we can turn this into a fraction and think about turning it over and multiplying it instead. So that's going to mean that we will be multiplying 2 plus square root of 3 over 2 times 1 over 2, which gives us square root 2 plus square root 3 all over 4. Because the 4 times, the 2 times the 2 is the 4. And if we want, we can simplify that. So we have the square root of 2 plus the square root of 3. Kind of strange having a square root inside of a square root. Kind of like a fourth root when you take a square root twice. And then that whole thing would be divided by the square root of 4, which is just 2. So that's a way we could leave our answer, or we could honestly just leave it as like a 1/2 times our square root of 2 plus square root of 3. So when we did this problem in section 3.1, we got a different answer. We got square root of 6 plus square root of 2 over 4. How can those answers look so different, and yet both of them be the cosine of 15 degrees? So let's go ahead and find an approximate value for this answer. I think we've done that before. Grabbing my calculator, I have the square root of 6 plus the square root of 2 divided by 4, and that's approximately 0.9659, etc. Then if we look at this answer we just got, put that in a calculator, I'm going to do 2 plus the square root of 3, and I'm going to take the square root of that answer, and then I'm going to divide that answer by 2. And I got 9.96592, etc. Same answer. And also, if I take my calculator and I type in the cosine of 15 while my calculator's in degree mode, I get exactly the same answer that way too. So they all match, and this is a valid way of finding that answer, even though it looks a lot different.